Hi, I'm Mr. V, and in geometry, I'm going to try to explain to you in brief what proof by contradiction is or how it would work. And basically, if something that leads to a contradiction can't be true, if something that leads to a contradiction can't be true, this means that the opposite must be true. Uh, Truth and falsity are opposites. If one exists, the other one can't. So this is the basic rule of logic. If proof by contradiction depends on it, so truth and falsity are mutually exclusive. So if a statement cannot be true and false at the same time. If the statement can be proven true, then it can't be false. If it can be proven false, then it can't be true. And if it cannot be proven true, then it must be false. And if it cannot be proven false, then it must be true. And this last piece is where we talk about the proof by contradiction. If you can't prove it to be false, then it has to be true. So let's look at a couple of examples. First of all, a triangle can have no more than one right angle. That's something that we could prove. We're going to prove it by contradiction. Let's assume that this is a false statement, that there are two angles that could be right angled in a triangle. So I'm going to draw a picture of a triangle here. Here's a triangle, and I have angle A, angle B, and angle C. We know that the three angles of a triangle sum to 180 degrees. So A plus B plus C is equal to 180. Now, if two of the angles were equal to 90, let's just say that angle A and angle B are both equal to 90. When I substitute 90 in up here for A and B, I get 90 plus 90 plus angle C is equal to 180. That means that angle C would have to be equal to 0, and you wouldn't have a triangle. That's a contradiction. So the proof by contradiction, you can't have two angles be equal to 180. So that means that this must be true, that only one angle can be 90 degrees. You can do the same thing with one angle must be obtuse. Now here's a second idea of proof by contradiction. The statement, which we could prove, is a radius is perpendicular to a tangent at the point of tangency. So here OA is the radius, line M is the tangent, and we're going to say that it has to be perpendicular. Now, if I'm going to prove this by contradiction, let's just say that this is not a true statement. This is that A is not perpendicular to segment OA is not perpendicular to line M. If that's true, that means there must be a point on line M that has to be perpendicular. So let's just call that B. And because if this point is not perpendicular, that means that there has to be some other point. And if this is true, I want you to notice that OA is a radius and OB extends beyond the radius. So this would have to be longer. OB would have to be longer than OA. But wait a minute. If OB is longer than OA and at point B we have a right angle, then the hypotenuse, that would be OA of this triangle, would have to be longer than OB. And that's a contradiction. You can't have the one be longer and the other one not, and yet the other one be longer and the other one not. So you can't have OB be longer and OA be shorter, and yet because it's a right triangle, the hypotenuse OA be longer and OB be longer. This means by contradiction that this must be true. And I know that this is a little bit confusing, but this is the beginning of understanding what proof by contradiction is.